This is the seventh in a series of videos on an introduction to APL. Here we're going to see some user function basics. User functions are a series of statements or programs written by a person, a programmer. They follow some simple rules. A user function is made up of several lines, called statements, and has a header and a body. The first line is the header, the other lines are the body. Functions can have as many lines as necessary. Functions may or may not take arguments, and functions may or may not return a result. If a function does not return a result, it is often called a program. A function may take two arguments. For example, plus is a primitive in APL in any other language that takes two arguments, one on the left and one on the right. Should you decide to write a function that takes two arguments, one will be on the left, the other one will be on the right. Those functions are called dyadic functions. A function may take a single argument. For example, factorial takes a single argument on the right. And if you decide to write a function that takes only one argument, it will be supplied on the right. Functions that only have one argument are called monadic functions. Finally, a function may take no arguments. There are no primitives in APL that take no arguments, but a user function may take no argument. Such a function would be called a niladic function. If a function returns a result, the result can be assigned and or used for further calculations. For example, plus returns a result that can be assigned to a variable or used elsewhere. All primitives in APL return a result, but not all user functions return a result. The header specifies the name of the function and the name of the arguments, if any, and the name of the variable holding the result if the function returns a result. For example, a function without any argument that returns a result will be written this way: the name of the variable to hold the result on the left, the assignment arrow, and the name of the function. A function that would take one argument and would return a result would be written this way. We put the name of the variable that will hold the result on the left, the assignment arrow, the name of the function, and the name of the right argument. A dyadic function, one with two arguments, that would return a result would be written this way: the name of the variable that would hold the result on the left, the assignment arrow, the name of the left argument, the name of the function, and finally the name of the right argument. Similarly, functions that do not return results would be described this way. A niladic function without any arguments would just be supplied with simply the function name. There is no result, so there is no name for the result variable. There are no arguments, so there's only the function name. A monadic function would only have the function name and its right argument. And a dyadic function that still returns no result would only have the left argument and the right argument around the function name. Here's an example of a dyadic function that returns a result. The header line contains the name of the result variable, which is called hip. Then there is the assignment arrow. Then there is the name of the left argument called height. Then there is the name of the function called Pythagoras. And finally, there's the name of the right argument variable called base. And on line 1, the only line in the body of this function, we see what the function does, and it assigns to hip the value of the square of height plus the square of base, the entire thing being exponent 1/2, which is the square root. So the line of this function here describes the entire process. What is done with the height, what is done with the base, and where the result goes. Hip is the result, height is the left argument, Pythagoras is the function name, and base is the right argument. Here's one monadic function with a result. sRoot is the name of the variable that will hold the result. sqrt is the name of the function. Numbers is the name of the right argument. Line 1 only has a comment, nothing happens there. This line only explains what this function does. And the bulk of the work is done on line 2, where the square root of numbers is extracted and assigned to sRoot. Finally, here's a niladic function with a result. This function takes no arguments, but simply returns a result. Line 1 is a comment, and line 2 is simply summing the roll of 2 dice. This function takes no arguments. In the last 3 examples, the result could be used in further calculations. For example, SQRT16 returns 4. We could have used that result and added 3 to it to get 7. Here's an example of a function that doesn't return any result. It's a dyadic function. There's a left argument, there's a right argument, but there's no result. Even though on line 1 the result is assigned to variable hyp, this is not returned by the function. On line 2 a message is displayed, but no result is returned. Here's an example of a monadic function that doesn't return a result. It takes a right-hand argument, again does not return any result. Line 1 is a comment, line 2 displays a message, and there are no results returned. Finally, here's an elatic function without a result. The header only contains the name of the function or the program. Line 1 computes the simulation of throwing 2 dice, and line 2 displays a message. There's no result. In the last 3 examples there was no result. This type of function is typically used to display results or have other side effects like interacting windows, updating databases, and so on and so on. Those are often called programs. So, to recap, user functions come in various flavors. They may take up to 2 arguments. They may return a result. Functions that do not return a result are typically used to produce side effects like screen interaction or file updates, databases, and so on. That's it for this video.